All right, welcome, ladies and gentlemen. My name is Brian McLogan, and this is week 2 of our Q&A. So I'm actually going by the calendar week 2. I'm going to kind of reset, but thank you for showing up for the live stream. Hopefully I'll be able to answer some of your questions. I did get a lot of questions for this upcoming live stream, and I'm also seeing that I'm getting plenty of you guys inside of the chat. So therefore, I do apologize. I'm not going to get to everything, guys, but I just want to kind of give you guys a little heads up here of what I'm going to kind of at least cover tonight. So therefore, if you did submit a question, you can kind of see where I'll kind of stand inside of there. Or if you have a question of your own that maybe you submitted, you can maybe kind of see some of them I kind of combined into one. So we're going to work on graphing, just I think using transformations with absolute value, reciprocal, identifying asymptotes, as well as graphing rational functions, looking into identifying the volume of a sphere. Let's see, talking about the zeros, end behavior, multiplicity, turning point, as well as graphing. We are going to, let's see, cut that out. Look into graphing a quadratic, talk about some different ways to do that. Graphing a radical, a lot of graphing going on, combining rational expressions, and then factoring a sum of two cubes. So I see there was a lot of you guys that submitted some questions, as well as a lot of you guys that went ahead and added in some questions into the back. Sailing Cam, I see that you added into, again, some extra things on exponential equations or functions. I'll try to get to them. I'm going to get to these 8 and we'll kind of see how long this takes for you guys. But again, I can, there's a lot of questions I didn't either have enough information for what you wanted me to cover or specifically to address. So therefore, I just wasn't able to add it to the stream. So I just advise, guys, if you do have questions that you are submitting, either if it's a, specific question, like, solving this type of equation or something like that, or kind of let me know a little bit more details. But a lot of people just kind of gave some topics, like a very broad topic. And it's very kind of difficult for me to understand what you have, because I just want to give you guys a little heads up. I really, get into, I go ahead and look at the comments on the, I try to look into the comments, roughly between an hour and 30 minutes before the live stream. So if I don't have a very good idea of what I need to talk about from your general question, I'm just not going to be able to really answer it. So if you guys do have questions, obviously I'll try to answer some questions maybe that I'll be able to get to on the chat, guys. But again, the best way for you guys to utilize that chat is obviously besides interacting with each other, but also be able to help each other answer some of those questions in the chat as well. So thank you, Mr. Beast, for your super chat, $1.99. I do appreciate it. I believe you asked a question, and yeah, the rational expressions I'll be covering for you. So I do appreciate the super chat. Thank you so much. So I'm ready to donate later. So I see, let's see here. We got Armando, Mason, TNS Lover back again. Awesome Fortnite. Good to see you. KTS, Sailing Cam, Cindy Martinez, Haler BMVs, Mason Smith, Ben Modiano. Good to see you guys. Thank you so much for joining in. David, thank you guys. This is great to have you guys here, and I'm really excited to do another live stream and get some of your questions answered. And if this is the first time you've joined one of my live streams, I do go live every Sunday night at 9 p.m. And then I do make a post on my community tab. So therefore, if you're not following in my channel, subscribed, then make sure you go ahead and take a look at the subscription to look at, and as far as the notifications, so therefore you can get updated when I post on that community tab. So therefore you can get your question posted, and therefore I'll see what I can do to answer them on every live stream. So also, for those of you guys that are also community members, I always take those questions kind of in priority if that is something that is of interest to you. I do also have some things with my uploads and else that I'm doing in that membership side. But on to this live stream, on to your questions. So first one, we're just going to talk about graphing. So I think when we're looking into graphing these functions, we really just want to kind of understand, 1, the parent graph, and then 2, understand the transformations. So first thing is, let's make sure we understand what these graphs are. So the parent graph of f of x equals, I'm just going to do f of x instead of y. Absolute value of x, that graph is what we call, like the V-shaped graph, right? The graph is going to look something like this. Now, what we need to understand is, what are all these transformations? So what we need to understand here is for any function, a times, I'm not going to deal with b. Let's just do x minus c plus d. Okay, so whenever we have any function, if it's in f of x notation, when we multiply that function on the outside, all right, that is going to be a vertical stretch or compression. If that number is negative or less than 0, then that is going to be a reflection about the x-axis. So as you can see here, we're multiplying on the outside of our function, absolute value of f of x, by a negative 1. So therefore, that graph is going to be reflected down. So now I'm going to have this graph reflected down. Remember, any transformations inside of the function is going to be a horizontal shift. So this x plus 1 is going to be shifting the graph 1 unit to the left. It's actually the opposite of c, so therefore that's why it's going to the left. And then since we're subtracting a 2 on the outside, that's going to shift the graph down 2. So typically when you have a function using transformations, you're going to at least have one point that you can kind of move, and then we just really kind of work from sketching the graph from there. So I know instead of the graph going up, it's now going to go down because it's being reflected about the x-axis. It's going to be shifted 1 unit to the left and then 2 units down. So 1 unit, 2 units down. So therefore there's my new vertex. And then it'll look just like that. And again, I'm just doing a rough sketch. I'm not going to go through the whole, getting everything perfect. For the next one is, let's go ahead and graph y equals f of x of 1 over x. So this graph is a little bit difficult for students just because there's no x and y intercepts here. There's actually a horizontal asymptote at 0 and a vertical asymptote at 0. And this actually produces a graph which we call the hyperbola. So it looks like this. So there's not an x and a y intercept, at least in that parent function form. However, we still kind of have this coordinate point of 0, 0, and that's where the x and the y axis occur. So therefore, now we just need to understand, well, really what are, again, of our transformations. Now, there's a couple different ways we can really write this 1 over 2x. You can really think about that as either a multiplying on the outside or on the inside, and that's where it kind of gets a little confusing. The main idea I want you to understand is it's going to be, since it's multiplication, it's going to be a stretch or a compression based on what you view. And also another important thing, just a kind of nugget to throw out there, just for those of you that are a little bit interested in learning more, this is an odd function, so therefore that's why it's not impacting it as far as that odd or if it's inside or outside, it's not really going to matter. But either way, that's a stretch or compression. In my class, I'm not really worried about students like getting the stretch or compressions exact. If we really wanted to have a detailed graph, we would either use graphing technology or we would use a table of values. But in my point, I just really want to get something, basic so we can kind of understand what the graph looks like. So here's my graph. This multiplying by 2 is going to be either stretching vertically compressing the graph or horizontally stretching the graph. And then also the graph is being shifted up 1. So since the graph is not being shifted left or right, the vertical asymptote is going to remain the same. But the horizontal asymptote is going to be shifted up 1. So I'm going to go up to 1, have that horizontal asymptote. And then to really kind of represent that compression, I'm just going to kind of draw a little bit fatter, something like that. Okay, it's not going to be exact, but again, we just want to have that general idea of what the graph is going to look like. I'm going to check in. I'm so happy my camera at least is working now this time. It was so odd last live stream to have to have my camera over here and talk about that. It was really odd. All right, now let's go and talk into the horizontal and vertical asymptote. I got 8 questions, so I am going to try to move along through this a little bit quicker than I can. And then again, I do see a lot of you guys are adding to the chat. Thank you very so much. If you guys can help each other out and answer some of those questions, especially some of you that are a little more advanced than other people, that anything you can help them or any resources, my videos or anybody else's videos, I really do appreciate you guys communicating and helping each other out to get to the point, because I'll try to do my best, but obviously I'm not going to get to everybody's question. All right. So one student asked how to find the horizontal and vertical asymptotes, and then another student asked to graph. So I typically don't graph rational expressions or rational functions just because it takes a little time. It's a little bit more advanced and it would take a while to kind of explain the whole concept. But what I will do is I'll kind of talk about how to identify maybe like the x and the y intercepts as well as the asymptotes. So first of all, let's talk about the horizontal asymptotes. Remember, the horizontal asymptote is basically what we have a test, which is called the horizontal asymptote test. And whenever the degree in the denominator is larger than the degree in the numerator, the horizontal asymptote is at y equals 0. Okay, so whenever the degree in the denominator, which in this case is 2, remember degree is the highest power, is larger in the denominator than the numerator, the horizontal asymptote is y equals 0. To identify the vertical asymptote, did I not do that? I did. Okay. To identify, no, I didn't. Why did I not do that? I think I meant to do that. Yeah, let's change that to that. Okay. So to identify the vertical asymptote, we are going to, we're basically just going to set our denominator equal to 0 to identify the undefined values. But again, remember there's two different types of discontinuities we've talked about for horizontal asymptotes. They could be holes or they can be vertical asymptotes. So we want to make sure nothing can divide out, be a removable discontinuity or a hole. And in this case, when we go ahead and solve this, we're going to get an x minus 3 times an x plus 1 equals 0. And therefore, you can see that nothing, both those values make the denominator equal to 0. So therefore, they would both be vertical asymptotes, and nothing really gets factored out. The other things, if I was going to graph this, the other things I would do is I would look for the y-intercept. Remember, the y-intercept is when x is equal to 0. So when you plug x equal to 0 here, what you would get is 0 in the numerator divided by -3. So therefore, you would get y is equal to 0. And then I'd also identify the x-intercept, which has been when y equals 0. Or reality, once you put y equals 0, you're going to multiply the denominator on both sides. You would just set the numerator equal to 0, and therefore you get x is equal to 0. So this just by circumstance happens that the x and the y-intercept are both at the origin, 0, 0. The other things we do is test for symmetry, plug in -x, see if there's any symmetry in the graph. And then once we have the x and the y-intercept, both the asymptotes, I would look into just plotting some points on both sides of the asymptotes to try to see that general shape in the curve. And just remember, the graphs are always approaching the asymptotes, so therefore that should better help you kind of sketch the graph. All right, so for this next example, we can see definitely some factoring can be playing along here, but so what we're going to do is we're going to want to simplify this equation first, just to make sure that we kind of understand at least what is going on in this case. So in the first one, I can factor out, so I have y equals, let's see, I can factor out a 2x. Did I just do a super chat on my own super chat? I just got that yes, somebody is pretending to be me and paying myself 99 cents. Thank you very much. I'm not sure if I should be worried or not. That is a very interesting play. Cheers, but thank you, I guess, for super chatting as myself. So in this first case, I can factor out a 2x. By factoring out a 2x, I am left with a x minus 1. Here, you can see I can factor out a 4. Now, by factoring out a 4, that was not supposed to be, why did I not do this? I'm sorry, I was trying to think of a problem. I made this problem up because they did not give me a problem, so I was trying to think of a problem that would work. So here, by factoring out a 4, I'm going to be left with a x squared minus 1. Okay, I think that's what I wanted. And therefore, I can factor this to an x minus 1 all over a 4 times x minus 1, x plus 1. Okay, so what I wanted to, my goal, I had to make this equation up. And again, I really do not like making up equations because you can see I didn't really make it up the way I thought I was making it up in my head. But what I was trying to create in this problem was a rational function where we had a quantity that got divided out. So x minus 1 is still a discontinuity, right? X cannot equal 1. But it's really important. The reason why x cannot equal 1 is, yes, it makes the denominator equal 0, but it gets divided out. So we could say, since x cannot equal 1, at x equals 1, there is a hole. Okay, so literally when we draw the graph, we're going to draw it just as it is, and we're just going to put a hole, whatever that y value is. So you could put you could plug 1 into the simplified version to be able to figure out what that y value would be to be able to identify the hole. And that would be for purposes of graphing the function. But besides that, now we have this we still are going to have the same degree in the numerator and the denominator. And for the horizontal asymptote, that's very important, because for the horizontal asymptote, since the degree is equal in the numerator and in the denominator, they're both 2, even when they get divided out, you still have a 1 over 1. So therefore, you're just going to take the leading coefficient of the leading coefficient. So in this case, we have leading coefficient of 2 over leading coefficient of 4. So that's going to be y equals 2 over 4, which is equal to 1/2. So that is going to be a horizontal line at 1/2. As far as the vertical asymptote goes, you're going to set the denominator equal to 0. But again, we know there's a hole here, right? So therefore, we're only going to take the 4 times x plus 1 equal to 0. And you can see this 4, that stretch or compression, is actually not going to be impacting the graph at all. We can just say x is going to equal -1. Now, as far as the x and the y intercepts go, we actually are both going to be at 0, 0 again. So that is just total coincidence. The x and y intercepts do not always occur at 0, 0. But if you were to go ahead and check it for this example that I created on my own, that is exactly what you would have. So I do apologize for that. But that is really kind of the extra step, I would say, as far as graphing. You know, you want to identify the asymptotes. There's also oblique asymptotes, which I didn't cover in this. But you want to make sure you can identify the asymptotes, the intercepts, as well as any kind of symmetry, and then just kind of plot some points to kind of round out the graphs. All right, the next one is find the volume of a sphere. So basically a sphere is going to be a, ball, kind of like a 3-dimensional. And really the main thing is, you have a formula, V equals 4/3 pi r cubed. And really, the way we kind of mess with these types of problems is just kind of give you different ways to have to figure out what the radius is going to be. And so I'm not really sure what else the student wanted me to cover. So therefore in this problem, I just want to make sure that you're aware of, making sure you know the formula. And then really the only piece of information you need to figure out, no matter what type of problem you're given, is what is that radius? And then basically you're just going to plug it in. It's either you're going to have a calculator or you're not going to have a calculator. In my case, I like to deal with things without a calculator just so it can be more exact as far as instead of approximating or rounding. So here I have 4/3 pi. You can see my r is 3. Okay, so 3 cubed, remember, is 3 times 3 times 3, which in this case is 27. All right. Now, again, we don't need to have the pi in between. We have 4/3 times pi times 27, so really order doesn't matter. So I can just kind of rewrite this. Okay, and 3 goes into 27. We obviously go 9 times. 9 times 4 is 36. So we just leave typically, and again, you'd want to read the question, make sure, does it say round or does it say leave terms in, or leave the answer in terms of pi, which would be, kind of that description there. So, but there's a little summary for finding the volume. All right, the next question. The next question was talking about the zeros of a polynomial. So I did a factored form because obviously if it's not in factored form, you would just want to factor it. But to cover everything that they wanted me to cover, I believe that they were looking into something that was in a factored form. So the first thing, identifying the zeros, is we're identifying the values that make this equation true when f of x is equal to 0. So therefore, you replace, the first thing you're going to want to do, actually let's save some space here. First thing you're going to want to do is replace f of x with 0. That is the definition of finding the zeros of a function. Well, now, since we have a product, since everything is in factored form, and if it's not in factored form, then you're going to want to put it in factored form. But since we have a product equal to 0, we can apply the zero product property. So we have x cubed equals 0, we have x minus 1 equals 0, and we have x plus 1 squared equals 0. Okay, so these are all what we call our linear factors, all right? And again, this x cubed equals 0 could also be written as x minus 0 cubed, okay? It's kind of a little weird to write it like that, but my point that I'm trying to bring in is that technically has a power of 1, that has a power of 1, and that has a power of 1. So when we have something written as our linear factorization, that is how we can identify the, actually, why don't I just get to the zeros? Sorry, I'll come back to that multiplicity in a second. So let's just go ahead and find the zeros because that's the basic one. So here I'll take the cube root. Sorry, I got a lot of things going in my head looking at what they wanted me to do. Add 1 to both sides. Here I have to square root first and then subtract the 1, so I get x equals -1. Okay, so those are my zeros. That is where the graph is going to cross. So if I had to graph this, I would plot those coordinate points. Here I'd have 0, I would have 1, and I would have -1. Okay, so that's where the graph is going to cross the x-axis. The next thing I need to do is I need to understand the multiplicity. Like, how is this graph going to behave at those zeros? Like, is the multiplicity, odd or even? Because basically, if the multiplicity is odd, that means the graph is going to cross. If the multiplicity is even, it's going to bounce. Furthermore, really the power, whatever the power of that multiplicity is, or the value of that multiplicity, that's how that graph behaves. So when we understand our parent graphs, like the linear, the quadratic, the cubic, the quartic, what we can see is how these graphs kind of behave as x-intercepts. So really, to understand the multiplicity, we got to look at that linear factorization, and that's what I was getting to I stopped. The linear factorization is basically when you have the polynomial written as a product of its linear factors. You can see that all of these are linear factors because they're all raised to the first power. That's x to the first power plus 1 squared, x to the first power minus 1. And again, this x cubed can be written like x to the 1, x to the first minus 0 cubed, okay? So this is our linear factors. And when we look at the linear factors, the multiplicity, so when we have a linear factor, x to 1 minus k, which would be, actually, let's do 0. I think 0 is the most common one used in textbooks. Okay, so x equals 0 is what we call the 0, and m, why is my thing going? M is the multiplicity. There we go. So m is going to be what we call the multiplicity. That is the behavior of the graph. So without getting into details, when it's odd, which in this case is 1, the graph is going to cross. At x equals -1, right? You can see here we got x equals -1. It was even, so it bounces. Now we don't know if it bounces up or if it bounces down. So we're going to just kind of draw something bouncing up and bouncing down. And then at 0, you can see it crosses, and really technically what it does is it has that behavior of a cubic. Now we don't really know how that behavior of the cubic comes through. So what we want to do now is identify the end behavior. So let's just say it crosses like this, and I'll kind of show you a little bit idea. So the next thing we want to do is identify the end behavior. So to identify the end behavior, you're basically just going to multiply this out. Now, you don't really actually need to multiply this out because you just want to figure out the first term. So x plus 1 squared is x squared, dot, 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 dot. Right? X plus 1 squared is going to give us x squared something. Now, if I were to multiply x squared times x cubed, you can basically just add the powers. The leading coefficient is going to be 1. So that's going to be x to the 6th plus dot, 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 dot. But again, to understand the end behavior, we just need to know that leading term, know that it's an even degree and a positive leading coefficient. So the graph is going to rise to the left and rise to the right. So again, that's going to be for the leading coefficient test. So I'm just doing a brief little summary. So as far as this end behavior, this cubic actually, so this graph is going to go through here. It's going to bounce. Then it's going to behave like a cubic. So it's going to do the little S curve, right? So that's really an S curve that crosses like a line, that bounces like a parabola. Then it needs to come back up. And it's going to cross like a line, going back to meeting my end behavior rising to the right. All right. So graphing a y equals x squared minus 3x plus 2, as well as graphing. So student asked me to graph quadratics. And again, like there's way more ways I could go about this. Like how am I going to graph quadratics? How can I graph quadratics in standard or vertex form? Like what exactly do you need help with? So I just decided just to do a quick little review on really both and just kind of generalizing like the differences. Because typically in Algebra 1, we go through, graphing something in standard form. And once we get into Algebra 2, we kind of more focus on the writing things in vertex form. Now, obviously, I'm not going to get into completing the square of rewriting this by completing the square into vertex form and doing it that way. That is an option. But let's just kind of review again the graph of a parabola. So let's actually do this real quick. Here is y equals x squared. This is the parent graph. Now, the parent graph has transformations, which we already kind of discussed. X minus c squared. Well, let's do h and k, actually. Why am I doing everything sideways? That's weird. All right, so this would be y equals a times x minus h squared plus k. Okay, by applying the transformations here, hopefully remember a is going to be your stretch, vertical stretch or compression. It's also, if it's negative, that's going to reflection about the x-axis. So x minus 3 is going to be shifting the graph 3 units to the right, and plus 2 is going to be shifting the graph 2 units up. So just by knowing those transformations, all I'm going to do is I'm going to take this graph, shift it 3 units to the right, and then 2 units up. And then I can just do a rough little sketch of that graph. Now, that's typically, that rough sketch, right, is good enough, typically. And because, but again, let's kind of remember, like if you were to use a table of values, then we want to kind of see, well, what are exactly those points? Like that rough sketch is like over 1, up 1, over 2, up 4, right? Because if you were to plug in 2, oops, I'm sorry, that's x squared, isn't it? If you were to plug in 1, you get 1. If you plug in negative 1, you get 1. If you plug in 2, you get 4. If you plug in negative 2, you get 4. So 2, we go 1, 2, 3, 4. And then if you went negative 2, that would be 1, 2, 3, 4. And you can see how that kind of works. If you go negative 3, that would be up 9. Positive 3, that would be up 9 as well. So you can see kind of how that graph would work. Now, when I have something in standard form, basically, there's a couple things that I want to use from this understanding. Is one, that a quadratic has an axis of symmetry. So we don't really need to figure out points that are on both sides of the axis of symmetry. We basically just need to identify the axis of symmetry. And then when we plug in that value of axis of symmetry, we're going to identify the vertex. Then we can just find points to the right of that vertex and then just flip them about the axis of symmetry. So to identify the axis of symmetry, then we are just going to say, or the line of symmetry, that is just going to be opposite of b divided by 2 times a. Now you might say, well, what is opposite of b divided by 2 times a? Well, remember, that's in standard form, ax squared plus bx minus c. So therefore, all we're going to do in this case is we are going to take the opposite of b, so that's going to be 3. Now this is not going to be a very nice, I don't know why I chose this. 3 divided by 2 times a, which is in this case is 1. So therefore that's going to be a 3/2. Then if I want to find the vertex, that is going to be opposite of b divided by 2 times a, comma, f of opposite of b divided by 2 times a. So basically plugging in that value. Now, I'm not sure why I chose this in the general thing, but I did. So we can go ahead and plug that in. So y equals, actually, you know what? I'm not going to do that because I just made up this problem. Well, I guess might as well. I don't know. Let's see. This is going to become 9/4 minus 9/2 plus 2. Yeah, might as well. So that becomes 9/4. If you want to get this to be a denominator of 2, you can multiply everything by 2 on top and bottom. So that'd be a 18/4, and then multiply by 4/4, which would give you a positive 8/4. So that is going to give you a -10, so that'd be a -1/4. Let's see if I did my math right, because I think the way that I was originally planning on graphing this was actually not using the vertex and the axis symmetry, but was actually using the x and y intercepts. Because again, you can check the x-intercept by plugging y equals 0. When you plug let's plug y equals 0, you get x squared minus 3x plus 2. You can factor that into x minus 2 times x minus 1, right? Yeah. So therefore, I identify right now, let's use that over here, positive 1, and so therefore I can say x minus 2 is equal to 0, and x minus 1 is equal to 0. So x equals 2, and x equals 1. Yeah, okay, that should work. And then also, we could also identify the y-intercept. I'm running out of space. Y-intercept is going to be at when x is equal to 0. So therefore, you would just get, when you plug 0 in for x, you get y is equal to 2. So 1, 2. And then my vertical asymptote is going to be here. And then remember, that was like at 1/4, right? So that'd be like right there. And therefore, in this case, I can get a general graph without actually using a table. But you can see, that's a lot more work than just knowing the transformations, right? But it was really important for you to understand, one, finding x and y intercepts, understanding the axis of symmetry, and understanding plotting points. So hopefully, depending on where you're at when you ask that question, hopefully I kind of covered some bases for you that you could apply. Obviously, once we get into higher mathematics, it's a lot easier just to do a general sketch using transformations, but this is very important as far as understanding that concept of graphing, as well as some applications that we continue to use. All right, for the next one, the student really wanted me to deal with the 2 times x or the 2x plus 1 because I actually haven't covered that. And that's something that's a little bit different when we're dealing with a function, a times f of b times x minus c plus d. So this is something that I covered at the beginning, but I didn't do the b. And again, the b is going to be a horizontal stretch or compression. But it's very important you see that in this general transformation form that b is factored out. So in this case, my b is not factored out. So what you need to do when you need to graph or identify the transformations and you recognize there is a b as well as a c, you need to make sure you factor that out. So typically people don't have a problem with factoring something out when it divides into something. But when it does not divide into something, that's really where it kind of gets confusing. But remember, like factoring out is kind of the same idea as like dividing out. So therefore I can factor out this x plus 1/2. Now I might say, well, how'd you get 1/2? Like where does that 1/2 come from? Again, all I'm doing is I'm dividing 2x by 2, which is just x, and I'm dividing 1 by 2, which is 1/2. And if you want to check my work, multiply it back. You can always check your work on factoring by multiplying something back. So 2 times x is 2x, 2 times 1/2 is 1. You can see that gives me back that answer. Now to graph this, we need to understand what the parent graph is, or what that looks like. So y equals square root of x. That graph looks like this from there. All right. So now we have a 2 on the inside. Now, if the 2 is on the outside, that'd be a vertical stretch. When it's on the inside, it's actually a horizontal compression. And then we have x plus 1/2. That's going to be shifting the graph 1/2 unit to the left. So my graph is going to be 1/2 unit to the left. And then it's going to be horizontally compressed. We don't need to be like kind of crazy on this, but we can say, I don't know, kind of looks something a little bit more like that. All right, I am running behind, guys. I do apologize. I take a quick little break just to say hello to Austin, Yup Legend, Halder, Brandon, the Kitty Gamer. Good to have you back on. CXLPZ, can I do substitution? I cannot do any more extra problems. I do apologize. But again, guys, feel free just to join, put those questions in on the community chat next week. I plan on going live again. I plan on trying to do 52 weeks. We will see. I just said that. I don't know why, but I'm really going to try to do it. So therefore, you guys can just plan on whatever math class you guys are taking. You submit your questions. Obviously, I cannot answer everything. I am not a math genius by any means. A lot of the math has been a very, very long time, and I do not give myself time to prep for a lot of questions. So the more details and specific you guys can get, the better I am able to determine what to cover, what to talk about, as well as what I remember about the topic that I can speak of. So make sure you guys get in that community chat and for next week, and I'll be happy to go ahead and do it. And thank you very much, Mr. Beast, again, for another 99-cent donation. I do very, very much appreciate it. Yes, Tina, as well, I have my old, I really want to. Hopefully, I'll be getting into a little bit more calculus next year when I have more time. I'm still trying to wrap up a lot of my curriculum right now for pre-calculus. So I'm hoping for next year to do a little bit more on the calculus side. But I do have a lot of the videos that I covered for calculus, a couple of years ago, that if that's something that you are interested in, I do have a lot of that. All right, guys, it is time for me to get this out or get these last two problems done. So we're going to do a a subtraction of two rational functions, and then we are going to do a sum of two cubes. All right, and just real quick, I just noticed, as William said, are there any books you can suggest for SAT? There are no books I can suggest for the SAT, not because I just don't have anything. That's not something I focus on. So I would just recommend looking at, some suggestions of people that have taken them, or just do some research in that. Hopefully that'll help you out. But again, really just practice is going to be the best. So there's probably multiple books that are going to get you set up. It just really depends on you putting in the work into it. So, all right, here we go. Subtracting two rational functions or expressions. Main idea, guys, is these are just fractions, so we got to get common denominators. Typically, if they don't have anything in common, we'd multiply them. But that kind of seems very difficult to multiply this times that. So let's maybe try to simplify this to see if they do actually have something in common. So I'm going to go ahead and factor this. And by factoring this, I know it can be broken down into a product of two binomials. And what two numbers multiply to give me 3, add to give me -4, I can say that's going to be x minus 3 and then x minus 1. And now I say that, oh, they do have something in common. They have an x minus 1 in common. So therefore, to obtain a common denominator, all I need to do is multiply by an x minus 3 over an x minus 3. Now again, please note I did a subtraction because notice that you're subtracting a 2. So when you distribute this -2, make sure you remember that's a -2, all right? And then I can also now go ahead and just combine these under the same denominator of x minus 1, x minus 3. So now I'll have 2x minus 1 minus a 2x, and then -2 times -3 is going to be a positive 6. All over x minus 3 times x minus 1. So I am kind of jumping over a couple steps for you. Instead of doing, minus and -2 times x minus 3, I'm just distributing that. 2x minus 2x is going to be 0. And then -1 plus 6 is going to just equal 5. So therefore, I'll just be left with a 5 times x minus 3 times x minus 1. And there you go. It's also important if you needed to talk about values that are excluded values. Those are going to be values that make the denominator 0. So a lot of times also we say x cannot equal 3 and x cannot equal 1. And that's just something very important to remember, especially if you are going into class where you're going to be dealing with solving rational expressions. So therefore, that helps us prepare our brain to go ahead and identify extraneous solutions, or at least check for them. All right, last but not least, guys, I have 8x cubed plus 1. So, excuse me. Royal Growth and the dollar. Thank you very much for the super chat, man. I really do appreciate it. All right, so let's go ahead and let's kind of review here. A squared minus b squared, that's going to be a minus b times a plus b, right? So if we're going to do something cubed, that's not going to, you just can't add an extra a minus b or an a plus b. There's actually a different equation. In this case, you can see we actually have a plus. So therefore, we're going to be looking for an a cubed plus a b cubed. Okay, so actually the formula, just so you can kind of have this, is going to be a plus b times a squared minus a times b plus a b squared. Okay, so that's basically the formula that you can go ahead and check it out. And again, just for those of you that are interested, we do have a sum or a difference of two cubes as well. So that is a minus b times a squared plus ab plus b squared. All right, so now what we need to do is basically identify, well, what is our a, what is our b, right? So if we want to write this in there, we basically want to write this as a sum of two cubes, like what cubed plus what cubed, right? So therefore, if we were going to say this is a and this is b, well, then we can say, let's have a cubed equal 8x cubed and b cubed equals 1. Now let's just go ahead and solve for a and solve for b. So to solve for a, we're just going to take the cube root on both sides. Okay, so the cube root of 8 is 2. The cube root of x cubed is x. When you take the cube root of b cubed, you're going to get b. And when you take the cube root of 1, you're just going to get 1. So now I know what a is and now I know what b is. Now all I'm going to do is plug it into that formula. So again, I have a plus b times a squared minus ab plus b squared. All right, so I have 2x plus 1 times what am I doing? 2x squared minus 2x times 1 plus 1 squared. And again, just notice my parentheses. A lot of times students will make mistakes, and they're just like silly mistakes just because not using parentheses. Remember, this is 2x squared, not 2x squared. So you got to make sure you square the 2 as well as the x. So therefore, I get a 2x plus 1, and therefore this becomes a 4x squared minus 2x plus 1. And there you go. All right, let's go and see. Can you factor 9x squared? How do you factor? You know, that's actually a good question. I actually want to cover that. That's actually a good one. So I'm going to cover that one. See what you guys get. Just a couple more extra questions. Thank you. AXD minus 8. Square minus 8. Because you can't factor that across integers. So let me kind of show them what to do for there. I have simultaneous equations that I'm doing for school. Okay, that's going to be, I would have to take a little bit more time for on that as far as the 4x and the xy. Sorry, Killer. Tacos, I'm not going to be able to do that. I need to work that one out a little bit more, and I'm just at the end of my stream. So I have a lot of doubts that I cannot ask here. Well, Yuppie Legend, you are more than welcome to reach out to me on Facebook. I do not do any private tutoring or spend a lot of time answering individual questions, but if you do, send me over a message, I'm always happy to kind of let students know either if it's something that I'm able to, help them with, or if I can send them to, maybe an idea that they should focus on. I can always do that. I don't have time to do a lot of private tutoring session. That's why I kind of designate here for my open live chat. And I see I start selecting some questions, and then here they go. More of them come in, but let me just look at them. How do I graph? It's an exponential function labeled 2 points and the asymptotes very clearly. I don't know. I'd have to take more time on that. Sorry, I just don't have time to look at that as far as 2 points. I mean, as far as identifying the 2 points, you can just plug in any number in for x. And then identify what the y value is. Look for values that are going to make your exponent 0, because that will give you a point of 1. So I would look at, a point to plug in for x would be something that would give 2x plus 2, make that equal to 0. So for instance, -1. So I'd plug in x equals -1 and then figure out what that y coordinate would be. And then as far as the asymptote, that's going to be anything that's going to be 0. That's going to be a vertical transformation. So if the horizontal asymptote was at 0, then you're shifting the graph up 2. If I understand your equation correctly, now the horizontal asymptote is going to be at y equals 2. So hopefully that at least gives you a little bit better in the direction there. Yeah, the table, you just got to pick values for x and then plug them into the table and solve for y. But yeah, it's kind of difficult with an exponential because you got to know what you're looking for. That's why I said use -1, because -1 makes your exponent 1. And you can deal with, or it makes your exponent 0, because anything to the 0 power is 1, right? And I would just kind of look into getting the exponent to be 0, get the exponent to be 1, get the exponent to be 2, get it to be values that you are comfortable with, so therefore you can create that table. How can I exact value without using the sum and difference, for example? You could use the double or the half angle. I do not have time to cover the double and half angle. We will be getting it, though, into my class very soon. So I'll probably maybe cover that next live stream. And also I have a ton of videos on that. But yeah, I'd look into 7 pi over 8. You could do the half angle formula. So I would use the half angle formula if you do not want to use the sum or difference. And so how do you use mapping notation? I'm not sure what context you want me to talk about that. And I'm not sure how you factor what you're giving me. Okay, guys. I'll just kind of work on this one because it was something that, how do you factor this? Was it set equal to 0? Yeah, it is equal to 0. So I'm not sure what the student was asking as far as how to factor this, but I think what they mean was how to solve it. So what I would do is, because this isn't factorable across integers, so what you want to do is, since you only have one variable, x squared, I would just isolate the variable. So I would just undo everything that's happening to the variable. So let's look at what's happening to this variable. This variable is being squared, it's being multiplied by 9, and it's being subtracted by 8. So using inverse operations and the reverse order of operations, I'm going to undo addition first. Then I'm going to undo multiplication by dividing. And then I'm going to have an x squared equals x, 8 over 9. Whoa. Okay, now to undo squaring, I'm just going to take the square root to both sides. Remember, when you introduce the square root, that has to you're going to include the positive and the negative solution. So x equals plus or minus the square root of 8 over 9, which can be broken down or broken into the square root of 8 over the square root of 9, which can be broken down into square root of 8 can be rewritten as 2 square root of 2. The square root of 9 can be 3. So maybe let's write this as plus or minus 2/3 square root of 3. Okay, so that is the solution. So if the student said find the solutions, that's what I'd say would be the best. The student also talked about factoring, and this kind of goes back to that zeros thing, is like we found the zeros from the factors. So what if I give you the zeros, can you write them as the factored form? And this student, if you wanted to write the factored form, you can do that from finding the zeros. That's basically going to be x minus 2/3 square root of 3 times x plus 2/3 square root of 3. So only if you really needed to have that linear factorization or to understand that, would that be kind of helpful. But therefore, the student did ask about factoring. So a lot of times, if something's not factorable across integers, it's best to go ahead and find the zeros and then rewrite them as their factors. But guys, I do appreciate you. I know you guys sent a lot of questions. I do got to go. I have class tomorrow and I have to prep still for that. So I do apologize, guys, but please make sure that you guys get your questions into me next week. I've been trying to, I made the community chat or the community post on more than 24 hours, like 24 hours in advance. So make sure you guys have your time to go ahead and check on that. I'll plan on being back here next Sunday at 9 p.m. and I look forward to answering your questions. So until then, guys, I will see you on the next stream. Cheers.